Jensen Huang established NVidia 30 years ago with the goal of revolutionizing gaming with 3D graphics. Jensen bet the company on something quite different after nearly going bankrupt, and that was artificial intelligence. Surprising, right? That bet is already paying off handsomely, and you might be wondering how they got from gaming to AI. How did AI assist them in reaching such heights? In this video, we explore NVIDIA's remarkable growth using AI. To know more about this, join us. NVIDIA, founded in 1993, is a prominent GPU manufacturer with advanced computing capabilities while partnering with the software community. By inventing high-performance graphics chips and using computer graphics in video games, NVIDIA revolutionized gaming and Hollywood with the rapid creation of visual effects. NVIDIA's 2006 release of the CUDA software toolkit pushed it to the top of the AI boom by changing NVIDIA's GPUs from serial to parallel handling. The graphics processing units from NVIDIA are well optimized for parallel computing, which is important for training large-scale language models. GPUs are capable of performing multiple computations at the same time, making them ideal for deep learning tasks such as NLP. GPUs can improve the performance of real-time 2D and 3D graphics applications. GPUs have improved video editing and video content development. For example, video editors and graphic designers can employ a GPU's parallel processing to speed up the rendering of high-definition video and graphics. Because video game visuals have gotten more computationally complex, emphasis has been placed on high-performing GPUs in order to keep up with display technologies such as 4K and high refresh rates. GPUs can speed up machine learning. Workloads such as image recognition can benefit from a GPU's high processing capability. GPUs can help CPUs do more work by training deep learning neural networks for AI applications. As part of an analytical model, each node in a neural network executes calculations. NVIDIA's GPUs are popular among researchers and data scientists because of their great computational capacity and effective parallel processing, making them ideal for deep learning applications such as natural language processing. NVIDIA's Kepler GPU architecture has been designed from the ground up to provide not only ideal performance in the most recent DirectX 11 games, but also ideal performance per watt. The new SMX streaming multiprocessor is twice as efficient as the predecessor, while the new geometry engine draws triangles twice as rapidly. Large-scale language models such as ChatGPT necessitate a huge amount of computer resources. The training process is sped by employing NVIDIA GPUs, allowing for the creation of larger and more complicated models. Furthermore, NVIDIA's tensor cores enhance mixed precision training, reducing the amount of memory needed for training and speeding up the training process. The tensor core is a crucial technology in NVIDIA's latest generation of GPU microarchitecture releases. With the support of autonomous mixed precision training, these specialized processing subunits, which have progressed with each iteration since their introduction in Volta, enhance GPU performance. NVIDIA's proprietary parallel processing platform and API for GPUs is CUDA, whereas CUDA cores are the standard floating point unit in an NVIDIA graphics card. As a defining element of NVIDIA GPU microarchitectures, these have been present in every NVIDIA GPU released in the last decade. Each CUDA core may perform calculations, and each CUDA core can perform one operation each clock cycle. Although less powerful than a CPU core, numerous CUDA cores may accelerate calculating by running processes in parallel when used together for deep learning. CUDA cores were the defining hardware for accelerating deep learning prior to the arrival of tensor cores. GPUs limited to the performance of CUDA cores are also limited by the number of available CUDA cores and the clock speed of each core because they can only operate on a single computation per clock cycle. To address this limit, NVIDIA built the Tensor Core. So Tensor Core helped to build AI innovation. NVIDIA made mistakes in its approach to smartphones, issued multi-computer graphic cards that bombed, evangelized fads that was outmaneuvered by regulators and rivals in its $40 billion bid to acquire chip manufacturer ARM Limited. Huang has a well-ingrained survival instinct. It might mean canceling a project ruthlessly the minute he realizes NVIDIA isn't going to win or painful senior workers to make a point. He is proud of nearly going out of business 7 times and is eager to take these risks again and again since they may one day help him in the future of computing. It's also helping other companies create their AI solutions, making it a critical link in the AI chain. Will this really benefit NVIDIA? NVIDIA has risen to the forefront of the world's most essential technology. It controls 80% of the market for a type of chip known as a data center accelerator. and one of its AI processors currently has an 8-month wait period. NVIDIA's backlog includes many large technology companies. However, several of Huang's most important customers have been designing their own proprietary chips for years in order to reduce their reliance on suppliers such as NVIDIA. They're hooked for the time being. The Ampere 100 is what makes AI possible. The ChatGPT poetry, the software for self-driving cars, the computer-generated photo of the Pope in a puffy jacket. The chip is about the size of a matchbook and is named after the 19th century French physicist André-Marie Ampère. Its surface appears smooth until inspected through a microscope, revealing over 54 billion microscopic components arranged in what appears to be a map of Tokyo's underground infrastructure. Alphabet, Amazon, and Microsoft have also invested heavily in semiconductor design. Google's tensor processing units have made great progress. Midjourney, a popular AI image generator app, said in March that it would use Google's processors alongside NVIDIA GPUs for model training. According to New Street Research LLP, Google's processor provides up to 6 times the performance per dollar as NVIDIA's A100. But there are trade-offs. Google's data processing is less flexible and the advantage won't last more than a year or two. The Hopper 100, named after pioneering programmer Grace Hopper, is the A100 successor and already equals the performance of Google's CPU. According to Pierre Ferragu, an analyst at New Street, even the most prominent people in the industry are behaving very, very politely towards Huang. Everyone is afraid of upsetting NVIDIA. When asked about dangers to his firm, Huang remains silent. He dismisses consumer objections about the cost of NVIDIA GPUs, claiming that because they're so efficient, a client pays less to power his workstations in the long run. So how did NVIDIA become such an important part of the AI revolution? Mr. Huang was the one who made this critical decision for the advancement of AI as we know it. He used NVIDIA's resources to develop a tool that makes GPUs programmable, allowing them to be used for purposes other than graphics. That tool was incorporated into NVIDIA's computer processors. It was a capacity that computer game players didn't require and probably weren't even aware of, but it was a novel means of doing high-speed computing on consumer hardware for learning. That skill was essential in sparking early breakthroughs in modern AI. AlexNet, an AI capable of picture classification, was introduced in 2012. AlexNet was trained using only 2 programmable GPUs from NVIDIA. The training process was completed in a matter of minutes. NVIDIA capitalized on its edge by investing in the development of new types of GPUs that are more suited to AI, as well as more software to make the technology easier to use. ChatGPT, an AI that can offer disturbingly human-like responses to inquiries, surfaced a decade and billions of dollars later. AI venture using AI technology, Metaphysic, generates photorealistic videos of celebrities and others. In 2021, its Tom Cruise deepfakes caused quite a sensation. It employs hundreds of NVIDIA GPUs to train and then execute its models, some purchased from NVIDIA and others obtained through a cloud computing service. Google has tensor processing units which are utilized for not only search results, but also certain machine learning activities, whereas Amazon has a custom-built processor for training AI models. ChatGPT can be used for inference after it's been trained. The inference mechanism, which involves anticipating the most likely response to a given input, is powered by NVIDIA's GPUs. NVIDIA's GPUs' highly optimized parallel processing capabilities make them perfect for conducting the inference process in real time. NVIDIA GPUs are essential in enabling ChatGPT's powerful hardware and software architecture. They offer faster training times and improved model accuracy, allowing for the development of large-scale language models capable of understanding and responding to human language. NVIDIA GPUs are going to remain an important tool for the construction of complicated language models as the discipline of NLP evolves. The demand for GPUs will create a massive market for NVIDIA to handle, not just in its main industry of gaming and data centers, but also in autonomous vehicles and a variety of other technologies. So what do you think about this conversion from gaming to NVIDIA AI applications? As AI takes place everywhere, will it affect future innovations? What are your thoughts about this? What are your predictions for the upcoming AI innovations of NVIDIA? Will NVIDIA destroy already existing innovations? Share your thoughts in the comments section below the video. Thank you for watching the video, and if you find this video informative, please give a thumbs up and subscribe to our channel. Also, don't forget to click on the bell icon in order to get updates on time. See you in the next video.